Now we're going to look at the time value of an annuity. Many business transactions are structured as a series of receipts and payments of cash rather than a single amount. If we are to receive or pay the same amount each period, we refer to the cash flows as an annuity. Familiar examples of annuities are monthly payments for a car loan, a house loan, or apartment rent. Of course, payments need not be monthly. They could be quarterly, semi-annually, annually, or any interval. The key is as long as the cash payments are of equal amounts over equal time intervals, we refer to the cash payments as an annuity. Let's suppose that you decide to invest $1,000 at the end of each year for the next 3 years, earning 10% compounded annually. What will the value of these $3,000 payments be at the end of the 3rd year? This slide demonstrates how to calculate the future value of this annuity. By the end of year 1, the investment's future value equals the $1,000 annuity payment. No interest has been earned because you invested the $1,000 at the end of the year. By the end of year 2, though the first annuity payment has grown by 10%, $1,100, it's grown to, which is the 1,000 times 1.10, and you make the second $1,000 annuity payment. Now adding these together, your total investment has grown to $2,100. By the end of the 3rd year, the first annuity payment has grown by another 10%. It's grown to $1,210, which is the 1,100 times 1.10. The second annuity payment has grown by 10%, which is the 1,100, which is the $1,000 times 1.10, and you make the final $1,000 annuity payment. Add these together to find that the total investment has grown to $3,310. This is the future value of a $1,000 annuity for 3 years at 10% interest compounded annually. Since annuities consist of multiple payments, calculating the future value of an annuity can be time-consuming, especially as the length of the annuity increases. So to make this task much more efficient, we can calculate the future value of an annuity using the time value of money tables located at the end of the book. This is Table 3. We calculate the future value of an annuity, FVA, by multiplying the annuity payment by the factor corresponding to 3 periods and the 10% interest rate. 3 periods, 10% interest rate. This is the factor we would use. We could also calculate the future value of an annuity using a financial calculator. So to compute the future value of an annuity, you simply input 3 amounts, payment amounts, interest rate per period, and the number of periods. Make sure the present value is set equal to 0. This slide shows the inputs and output using a financial calculator. Now this slide shows the Excel method for calculating the future value of an annuity. So I'm going to go over here, try to do it for you. $1,000, 10%, and periods would be 3 periods. I don't know why it's giving me a, don't want that. I'm just going to key that in the formula. So we're going to go to future value, and the rate is 10%. The number of periods, 3. The payment is 1,000. Present value is 0. Correct? So we see here that the amount in the future would be 3,310. Let's look at an example. So let's suppose Warner Brothers borrows $300 million to produce another Batman movie and is required to pay back this amount in 5 years. If at the end of each of the next 5 years Warner Brothers puts $50 million in an account that is expected to earn 12% compounded annually, will the company have enough cash set aside to pay its debt? Well, the future value of a $50 million annuity over 5 years that earns 12% annually is going to equal $317,640. How do we calculate that? We're going to go to Table 3. The amount, the payment is $50 million with a period of 5 years, an interest rate of 12. We'll take the factor 6.3528. So if we put in $50 million each year over 5 years, that gives us $317,640. I think I missed some zeros there. $317,640,000. Warner Brothers will have enough to pay the $300 million debt. Let's look at another example. You want to become a millionaire in 40 years, but you don't have much money. Isn't that the story of all of our lives? If you set aside just $2,500 at the end of each year with an average annual return of 10%, how much will you have at the end of 40 years? Remember, we're trying to look out the future value of what $2,500 a year will give us with a 10% interest rate for 40 years of investing. So again, we would use Table 3, and we would find the factor for the amount where n equals 40 and interest is 10%. So 2,500 over 40 years would be 2,500 times 442.5926. I have 25,000 and that is wrong. I am sorry. That's going to equal $1,106,482. So we would be a millionaire after 40 years. Now, let's say that instead of it averaging a 10% interest rate, it's only going to average 8% interest rate. So then we would go and use the factor based on n equals 40 and interest equals 8. If we do that, as you can see, we're only going to get $647,641. Again, that should be 2,500 times 259.0484. We would only have $647,000, way short of our goal. Then the last example, what if that amount is 12%? Well, if it's 12%, we would use the factor based on n equals 40, I equals 12, 767.0916 factor from Table 3. And our 2,500, again, sorry, not 25,000, would yield us $1,917,729. You see how significant that interest rate plays out into these formulas. In a future chapter, we are going to learn that certain liabilities are reported on financial statements at their present value. Now, most of these liabilities specify that the borrower must pay the lender periodic interest payments, or what we call an annuity, over the life of the loan. As a result, we use the present value of an annuity to determine what portion of these future interest payments the borrower must report as a liability today. So that is an application for what we're talking about. To understand the idea behind the present value of an annuity, you need to realize that each annuity payment represents a single future amount. We calculate the present value of each of these future amounts, and then we add them together to determine the present value of an annuity. As shown on this slide, the present value of three $1,000 annual payments discounted at 10% equals the present value of the first payment, $909, plus the present value of the second payment, $827, plus the present value of the third payment of $751. You can verify these amounts by looking at the present value factors in Table 2. So, what we did here is Table 2, and we can take each one of these payments and use Table 2 to calculate what the present value would be. So $1,000 in the future for one period at 10% would be a present value of $909. $1,000 in 2 years at 10%, we would use 2 periods, 10% interest rate, and we would use the 0.82645 factor to come up with a present value of $827. And then the present value of $1,000, where there's 3 periods at 10%, we would use the factor 0.75131 to give us our $751. When we total those numbers, our present value of that future annuity is $2,487. Now, that's a lot of work. So instead of calculating the present value of each annuity payment, a more efficient method is to use the time value of money tables shown on this slide. This is Table 4 in your book. We calculate the present value of an annuity by multiplying the annuity payment by the factor corresponding to 3 periods and a 10% interest rate. So you see, we go to the factor where it lines up 10% interest rate for 3 periods. The 2.48685 factor times $1,000 gives us the present value, the same figure, the $2,487. Once again, we can use a calculator to calculate this information, or we can use Excel, where we calculate the present value at 3 periods and $1,000 a period. I'm going to try to do this in Excel. So instead of future value, we now are going to go to Financial. We'll go to the present value, and the rate is 10%. The number of periods is 3. The payment, I'm going to put in minus 1,000 so we end up with the correct amount. The $2,486.85. Let's look at an example. A movie theater considers upgrading its concessions area at a cost of $10,000. The upgrades are expected to produce additional cash flows from concession sales of $2,000 per year over the next 6 years. Should the movie theater upgrade its concessions area if its discount rate is 8% annually? So, should we spend this money? So, we need to know, is it going to pay off for itself? So the present value of a $2,000 annuity over 6 years at 8% is $9,245.76. We're using the period of 10%, we're going to use 8% over 6 years. So we're going to use the factor 4.62288 to calculate this equation. 2,000 annuity over 6 years, 8% over 6 years, this is the figure we'll calculate. This comes up to $9,246. So the present value of a $2,000 annuity over 6 years at 8% is $9,246. So the $10,000 cost of the upgrade is greater than the present value of the future cash flows of $9,246 that's going to be generated. So in my opinion, the theater probably would be better off not making that investment because it's not going to benefit. Here's another example. Each year you play a Monopoly game at McDonald's. This is your year. You peel back the sticker and you realize you have Park Place and Boardwalk. You've just won $1 million payable in $50,000 installments over the next 20 years. Assuming a discount rate of 10%, how much did you really win in today's dollars? Well, we've got to go to the table 4, where we take the present value, the interest is 10%, the number of periods is 20, so we go and lock in that number. The 8.51356 is the factor we will use. 50,000 times the 8.51356 yields 425,678 in the present value of what that money will be in the future. So the value today of $50,000 per year for the next 20 years is actually less than $500,000, but it's still free money. Here are a couple more examples we're going to look at. Manual saving for a new car. He puts $2,000 into an investment account at the end of each year for the next 5 years. He expects the account to earn 12% annually. How much will Manuel have in 5 years? We're looking to find the future value. So, in order to do this, the future value of an annuity, table 3, we would go to the table where n equals 5, interest equals 12, and we would calculate the factor of 6.3528. And that would give us $12,706 is how much Manuel will have at the end of 5 years. John puts $500 in a savings account at the end of each 6 months for the next 6 years that earns 8% interest compounded semi-annually. How much will John have in 6 years? So again, we want to look at the future value. Future value, table 3, we're going to look at, since it's being compounded semi-annually, we're going to look at number of periods, 6 times 2. They're being compounded twice a year. So we'll look at 12 periods where the interest rate is If it's 8% annually, it would be 4% semi-annually. So we would go to the factor where n equals 12, I equals 4, and find 15.0258. So that 500 times the 15.0258 gives us $7,513. Next, Anna purchases a ring with the selling price of $4,000 and will make 4 payments of $1,000 at the end of each quarter for the next 4 quarters. Now, assuming a discount rate of 16% compounded quarterly, what is Anna really paying for the ring? The cost today. So what we'll do is we're going to go to Table 4, the present value of an annuity, where we are going to show the number of periods is 4. The interest is 4 because this is going to be made each quarter. So we find the factor on Table 4 of 3.62990. That amount would be $3,630. So let's do problem or exercise 7 at the back of this appendix. You're going to start saving for retirement. Assuming you are now 25 years old and you want to retire at age 55. You have 30 years to watch your investment grow. You decide to invest in the stock market, which has earned 13% per year over the past 80 years, and it's expected to continue at this rate. You decide to invest $2,000 at the end of each year for the next 30 years. How much will your accumulated investment be expected to be in 30 years? So we know it's an annuity because we are investing each period. We know we are looking for the future value of the annuity. So you see the $2,000 payment, annual rate is 13%. The compounded interest is annually over 30 years. So we are going to look at Table 3, the future value of an annuity, where N is 30, I is 13. That future value would calculate to be $586,398.43. Well, there you have it. I hope this has been helpful for you. Again, you can find the Appendix C at the end of your book.